This section we've kind of done before, so you'll kind of have seen it because it's not directly limits. So the first thing says find a power function in behavior model for f, so the function, and then identify any horizontal asymptotes, so like basically just if there are any, state what they are. So all that's really stuff that we've done before. You probably just don't realize that like that's what we've called it before. So 40, if I can write, f of x equals negative 4x cubed plus x squared minus 2x minus 1. So basically, when I'm looking for the power function in behavior model, all it's saying is, like, if it's a fraction to, like, a rational expression, like, I'm looking at the highest powered, like, whole term, top and bottom, and writing them over top of each other. In this case, the highest powered thing, since it's just a single thing, is this negative 4x cubed piece. So my function would be negative 4x cubed. Actually, they don't even write it as equal. They just write the function. So that would be part A. And that's just because when we're thinking about in behavior, we're thinking as it goes to negative or positive infinity, what matters. And all that matters in a, like, I was about to say a linear function, and that's very clearly not linear. But in a function in general that's basically not rational is the very first highest powered term. So that's all I would be looking at for that. Horizontal asymptotes. Do I have a horizontal asymptote?
No, big on top there is not.
Yes. So
That's always how my brain goes.
So there isn't ever going to be one if it's not rational. But that's still a good way to think about it because technically that whole function can be written over 1, so bigger on top. No, there's not. So
Do you know if it's rational again?
if it's a fraction.
Oh.
Like a rational number is like 2 over 7.
I forget my math vocab.
Throwing it back to Algebra 1 here.
Yeah.
I just taught that.
Okay. You had a question in your mind.
They just had a quiz on that.
It's been a few years, you know.
It's fine. You know, they say when you get to calculus, it's the algebra that kills you.
Yes.
Like, you can do the calculus concepts, but it's like those little basic algebra things that you forget how to do.
That's how I feel. I keep like forgetting. The other day I forgot, like if you have something, or like if you have 5 equal to like 5 over 7, I forgot that you can multiply 7 by 5. I thought you had to like divide it on both sides. It's fine. I remember.
Yeah, once you get to the upper level stuff, doing basic math, even just like basic adding and subtracting can be difficult.
It's very difficult.
It's like you become so reliant on your calculator, you
I
like
know.
forget how to do these like basic things.
As I was doing in stats, I was adding up like when I was doing the conditional distributions or whatever, and it was like 36 plus 6. I added on my calculator. I was like, I'm not losing points for adding that wrong.
I mean, I get that.
Yeah.
I would do that. Just make sure my brain
Just
is
correct it.
thinking straight.
Yeah. I know I was telling somebody the other day, I said, you know, like, really, up until, like, Algebra 2, like, you really shouldn't let kids use a calculator, other than for, like, square roots, potentially. Like, I kind of get it with that. And I said something about, I think that a lot of times, like, kids just get so reliant on one that, like, they can't do, like, basic math skills.
Mm-hmm.
I said, I don't mind, like, you know, in pre-cal or whatever, if you, like, check, you know, 36 plus 6 to say that that's 42, but I would hope that you can say that that's 42 without your calculator. You know what I mean?
Yeah,
Like, so, I mean, and obviously at the end of the day, I don't know when you're doing a test or a quiz if you're typing that kind of stuff in and you don't know it or you're just doing it to verify, but.
And it's so like weird because I remember when we were in Algebra 2 with you, like we would always have to ask like, can we use our calculator? 'Cause we didn't need it for everything. So
Yeah.
sometimes you'd be like, no.
Well, that's why, like, the other day I was like, all right, y'all need your calculator now.
Yeah, for everything.
So it was just funny. They were like, oh, we need it? I was like, yes. That's why it was on the supply list. But in fairness, I did tell them they didn't need it till like halfway through chapter 3. But I forgot about this like one singular section that's in chapter 2. So I was like, well, y'all can just borrow one for now if somebody's willing to let you.
I got algebra 1.
Algebra 2. Algebra 1, we're getting ready to do square roots on Monday. I have to think through exactly how I'm going to do that with them. Perfect squares and stuff, like, obviously they should be able to do, but I have to decide if I'm going to let them use a calculator at all or not. Because the problem is if I do, that I'm going to have to do a separate part of their quiz and test that's just a calculator page. Because otherwise they'll just use it on basic adding and subtracting, and that's not right, so I don't know. I have to think through what I'm going to do about that. And if I'm going to go ahead and teach them to break them down, or if that's going to confuse them more.
Like if they're going to take out something.
But I think everything that they have in there is perfect squares, but they're just like numbers that they may not know, so I just have to think through how I'm going to do it, but I don't know. That's a problem for Monday. I'm just kidding.
Save that for later.
That's a Monday problem.
Yeah.
All right, so I need the power function in behavior model for this one. What would it be?
3x squared? Or is it just on
Is it 3?
So it would be this piece that's 3x squared over x squared, which reduces to 3.
That's what I said.
So then the horizontal asymptote would be what?
3?
Y equals 3. Turn the temperature up because it's freezing. It's a little warm.
It was cold in Miss Patton's room earlier. I feel like it always is though.
Yeah.
Like, hey.
Hey.
Hey. That's what she said.
Like, hey, 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 hey.
Hey, hey, hey.
It's for horses.
I remember when I first heard that joke. It's from Miss Greer.
Wasn't there another part to it? Did you
Hayes
ever
for
tell us?
horses. No, it's Hayes for horses. Something with a cow. Isn't it?
I have no idea.
I don't remember. I'll just search it up later. Also, it's like saying search it up, not like correct grammar. Because every time I say that, my dad makes or says it's
I say I'm going to search it or look it up.
Yeah.
Or
and
Google it is what I
when
usually say.
Search it up. He's like, that's like technically. He's like, I love how you say that.
I mean,
Like,
I've never
what?
heard anyone say that.
Oh well.
Maybe you should just ask Miss Patton.
Yeah. I'm too scared. Maybe like no.
And just be like, is it wrong to say I'm going to search it up?
She'd be like, I don't know.
She'd probably be like, well, it doesn't sound good.
Yeah.
Oh, this one also has x squared minus 4 on the bottom.
I need to ask her. I want to see what she'll say.
All right, what would how would I set up my power function and behavior model?
Negative x to the 4th over x squared.
Yep. Which would ultimately give me what as my model then?
Negative x squared.
Yep, negative x squared. And then horizontal asymptote.
This is y equals 0. Wait. Don't make me like that, Joe. Oh, big on top there is not.
I'm supposed to write y equals none.
Like, I literally just did that. Darn it.
I was like, why? What? I was like, what did I just
I know,
do?
I was too busy like thinking about it. I was like, y equals. I went a little ahead of myself.
Unknown's bad.
I figured one of them had to be 0, so I just said it.
Maybe on one of the odd ones.
Yeah, I guess.
I know sometimes it irritates me that they don't like intentionally set it so that like there's like one of each kind that's odd and one of each kind that's even.
I know.
It actually bothers me.
Like, I need examples of both. And, like,
That's why I have a hard time with the college algebra book because I don't have a teacher's edition, so I have to choose even problems. So sometimes I just sit there and I keep working even problems till I find what I'm trying to find.
That's so sad.
It's annoying.
You're like, we see you working problems. What are you doing? Homework.
Trying to find a problem.
Trying to.
I know today I was like, I need to do one that's like this. And so then I was like, all right, we're going to pause and we're going to do this one. I'm going to backtrack because we need to do something like this.
I would not draw this function. Math joke.
All right. Find a simple basic function as the right end behavior model and a simple basic function as a left end behavior model for the function. So y equals x squared plus e to the minus x.
E is a great number. E.
Y equals.
All right, hold on. I'm going to show you one out of the book first before we do this one so that we can kind of see what's happening. Just because there's not a lot of these in the examples. So, come on, buddy. Almost. Okay, close enough. All right, so down here it says let f of x equal x plus e to the negative x. Show that g of x is equal to x is a right end behavior model for f, while h of x equals e to the negative x is a left end behavior model for f. Oh, I thought you were trying to get closer to the board to see what I was doing.
I thought she was just gonna leave.
She's like, I'm out. Too hard.
I was hoping you wouldn't point to that problem. It's too hard.
All right, so we're looking at f of x over g of x. My iPad is like dark, but it's not actually like off. It just is like dulled over here, so I have to keep like checking it. Okay, so this is going to be a little different than the way we do it, but we're just going to have to basically like go through and just check ours to like actually come up with like what we need. But the limit as x approaches infinity of f of x over g of x, so f of x is the whole function, g of x is the right end behavior part. We set that up, split it into two fractions, but x over x is 1. So 1 plus e to the negative x over x equals 1, and that's because the limit as x approaches infinity of e to the negative x over x is equal to 0. Because basically it's like a really tiny number over a really big number, so it's basically 0. So we just say that that's equal to 1, and so like that's how we know that that's like the right one, I guess. And then when we do the left one, the iPad came back to life. The limit as x approaches negative infinity of f of x over h of x. So basically, as we're going to the left, so our left end behavior model, the limit as x approaches negative infinity of x plus e to the negative x over e to the negative x is equal to the limit as x approaches negative infinity of x over e to the negative x plus 1, which is equal to 1, because as we go to negative infinity, that's going to 0, which you can't really see. But you can also kind of find that from the graph itself. Like if you graph this x plus e to the negative x, which honestly, the way that we're going to end up doing the problems is pretty much with a graph, because it's not, they don't tell us to show that something is. Like you could check it by showing it, but we're going to end up pretty much just doing it with a graph because you can see it that way. But we have e to the negative x here on this side, so that's like the left side, and I can tell because then x, it's like a straight line here, which is the right side. So when we graph our functions, it'll be easy to tell which is the right and which is the left. So I usually just use the graph method because these are problems that you're allowed to do with a calculator. So going back to our problem. It's okay. We're just gonna graph it. It's easier.
I felt like I understood, but like to the point where I couldn't do it on my own, but I know what you meant.
Yeah, we're just gonna graph it. It's easier. Hold on, I need to turn my stat plots off.
Oh, why did I go to grab my phone? I literally went to grab my calculator, turn my phone.
Sometimes I go to grab my phone and I grab my calculator and vice versa, so
Yeah.
just depends on the day. So in y1, we're going to put this x squared plus e to the negative x. And zoom 6.
I was kind of expecting you to say that we were going to put something in y2. Because you're like, in y1 we're going to do this. And it's like, so. Are we doing anything else? I'm sorry, it kind of looked like you were writing rehab.
What does it mean
Pen
in
is
my,
glitching.
in my y equals? So like my y1 has the 2 lines, and then also my y2 has it, but then my y3 has all the dashes.
What? Let me see.
Like this out here.
Yes.
Okay, so Shepard was playing with your calculator, so
I
that's
know.
probably why. You do have to keep clicking it until it comes up with what you're looking for. It'll like do shading and it'll do like
Because my graph, my graph is literally a sink.
he had your calculator frozen so it wouldn't do anything and I had to fix it.
I want to know how he did it because I want to add my own picture.
The sync is apparently on every calculator like
Really?
that.
I didn't know that.
I don't know. They were playing with it when they were done with their problems today.
Wait,
I
so
was
what do I
talking
have to
about
do to
random
make it
upward.
go away?
Gotta figure it out.
Right in
and
behavior and left
left.
in behavior.
Yeah.
How do I make it go away?
You just have to keep clicking enter till it looks like what it's supposed to look like.
I think I prefer red than left.
And you know that if it's like highlighted or not highlighted, you can turn the graph on and off. Like the equal sign.
I'm so confused.
Did you get it?
Uh-uh.
Okay, look, arrow over to it, wherever it is,
Okay.
till it starts like flopping. And then just keep hitting enter until it comes back to the normal one.
For me, it's like when I hit enter, it brings transformation
Give
down.
me.
Okay. Oh, wait, never mind. I did it. Wait, maybe?
Give me.
Wait, it still looks different. Why is there no dash button? Oh, whatever. I think I was in the right spot.
Yeah, they were talking about if their calculators had like Python or whatever on it, and then they were all having a sync on their calculator, and then some other random pictures.
And he
And
made it where the graph, it looks like there's water going out. I want to know how he did it. Okay.
See that thing? It says quit app.
Yep.
Quit transform graphing.
Oh, thanks. Oh, so that means it's gone. Oh, no, it's still there.
What's still there?
The sink. Okay, I'm ready now.
did you type it in?
Wait, I still can't do it.
Let me see.
I go and I have it typed in, and I do zoom 6. And it says quit.
I mean, there is a plot
It
there,
says
so.
dimension mismatch. Wait, let me turn my stat.
Is your
off.
stat plot on?
Let me turn that off.
And then hit zoom 6 to make sure it's in the right function.
Okay, the sink is still there, but it works. I like it.
What?
I don't understand this thing.
I want to keep it there. I kind of like it.
What is the sync though?
That's so weird.
I wish I could add my
Also, your
own picture.
calculator's almost dead.
I know. I was gonna ask if I could charge it after this period.
I don't think that I have a charger anymore, but
Okay.
I have a
my
charger.
cable disappeared.
Oh, you
But
have a charger? Can I charge it next period? Do you have a block? I
No.
I have a block.
But
There's a
little
USB
thing.
outlet up here, so it would be fine.
There's also one over there, two over there.
Alright.
Yeah.
Our mascot.
Anyways, all right. So now we have our graph. What does the left side look like?
Goes up.
How?
Fast. And big.
Okay, what does e to the negative x look like?
It's kind of like it goes small.
Doesn't it go like that?
It looks like this.
It looks like that. Why did I thought it went the other way? I don't know why.
And then x squared goes like this.
Okay.
So the right end behavior would be
I need a bigger window.
x squared.
Okay.
The left end behavior would be e to the negative x.
Oh, is that all we have to do?
Yeah.
Oh. Okay. I think I can handle that. Oh, that's the next one. I'm not gonna know what.
48, y equals x squared plus sine of x.
Oof. I don't think the sine of x is really doing much.
That's what I was
Correct.
thinking.
I know
Both
it's
the
just-
left and the right are just x squared,
It's just there for moral support.
pretty much. That's why I changed it to zoom trig just to make sure.
Oh.
But ultimately, sine of x isn't really, because it's being added to x squared, it's really just like almost like shifting it by that much. It's not really shifting it a whole lot. So
I just did zoom trig and now I just have a line.
I didn't have anything when I did zoom trig.
Like,
Mine looks the exact same.
wait, no, maybe that wasn't zoom trig. But it was zoom trig. Let me try this again. Oh, yeah.
What?
Virginia, I'm gonna show this to you, okay?
Okay. What? I don't know what that is.
It's just a line that's on like the top half of the y-axis.
Oh, no.
That's it. Oh no, I don't like those two letters. Scary. Ah, that's a lot.
Well, what I'm going to say is you don't necessarily need to do all of these, but they're all kind of different things that are good about them. So, but I mean, really, you don't, I mean, you have time left today, but we also got till Wednesday for the quiz, so it's giving you plenty of time to do them. So,
And we have a physics quiz later.
I think you'll be all right. But after the physics quiz, I don't know if we're going to start the next section of physics, so you may have time to work on this then too.
After the physics